what is this aluminium, those aspects we will be covering. Then I will be just giving what is a new novel technique, a unique technique that is used for treating high strength aluminium alloys. It's just ALS, high strength aluminium alloys. What is that particular technique? And what is this effect on the properties on that particular aluminium alloys? And I will be concluding, what exactly we have found out. This is basically the basic of aluminium. Very, very interesting material. So these are the elementary properties of those things. It's a very light metal. Density, as you can see, it's about 2.7. Okay, good conductivity, melting point. Other things I have given. Very good machinability. Very, very important. From latest generation is the last one. It is very eco-friendly. What do you mean by it? It is thoroughly recyclable. See, this 21st century philosophy is you produce anything, it has to be eco-friendly. It has to be sustainable. Okay, so that is the key thing. So in that way, this aluminium sits on very, very important forefront domain. And to this, when I was in college, I used to add it is very, very academic friendly. The meaning that about 75% of our PhD is from aluminium only. So it is very academic friendly also. See, if you look at this aerospace domain, these are some prominent alloys. Over the decade, up to 2010, probably Dr. Gautam Rao might have shown this. Aluminium continues to dominate the equipment. So it is not that composite has come and completely aluminium has gone out. No, nothing like that. It is still continuing to be a very important alloy, irrespective of composites and magnesium alloy developments. If you take any aircraft and analyze, where and all different parts of aircraft and where and all aluminium alloys, straight away high strength aluminium alloy sticks. I have schematically presented where you can see this landing gears, central fuselage, air one, nose portion. See major portions, you can see different materials. You can see aluminium also prominently. This one. So it is relevant. It is not that what we are tapping is totally not relevant to today. No, it is very much relevant. See, aluminium alloys basically they are heat treatable or non-heat treatable. Majority 80% of is actually in rod products. Usually it is taken in form of extrusions, plates, sheets form. About 20% are produced through casting. It could be sand casting, die casting, pressure die castings, or investment castings. So what are the normal alloying? Aluminium itself has the lowest strength. We need to, when the engineering application comes, basically structural application comes, we require strength. So how do you attain strength in aluminium alloy? It is by alloying. See, these are some of the important alloying elements which goes into aluminium. Magnesium, manganese, copper, zinc, silicon, so like this. So what are these effects? Each one has got its own role. Each one has got different solubility. Depending on that, we should able to create alloys. So, for example, this copper, as you can see, it is hot shortness. It reduces hot shortness, decreases shrinkage, something like that we have given. Hot shortness means when you have cold work, when you are hot working. Certain materials will have a tendency to get converted into brittle and break. So that tendency is actually reduced by copper, apart from enhancing the strength. So like this, every element has got its own importance. So from corrosion point of view, or from strength point of view, or looking at the secondary processor, we can decide which alloying element is required, and we can form those alloys.
So what is the maximum optimum level we can use copper in aluminium?
Actually, see, 3.5 to 5.5, that's what I remember. I will just come to that. In general, if how these aluminium alloys are designated. So in the title I had mentioned 7X series of alloys. How exactly is designated? That's what I am trying to give here. It is usually a 4-digit designation system for hot aluminum alloys. Okay, you can see it is 1x, 2x, 3x, like that. So if the major component alloy element is copper, it is designated as 2x series of alloys. Manganese, it is not that only copper. Along with copper, you can have something. Okay, similarly, zinc, if it is major element is zinc, we brand it as 7x series of alloys. In fact, along with zinc, okay, certain amount of copper and other elements will be there. So major alloying element, based on those major alloying elements, okay, this is designated in this way: 1x series, 2x series, 3x, 7x. So what we are going to integrate in this lecture is 7x series of alloy.
Why 5x is not
It is this. Okay, I will just come back to that. Now, see this based on these particular aluminium alloy. Okay, when you form, you can grade into 3 different groups: age hardening alloy, cast alloy groups, and probably strain hardening groups. Cast alloy means it is produced through casting. Probably age hardening group means we attain strength through precipitation hardening. And strain hardening means some indication I have given. So it is actually through cold working. We deform the grain structure and try to build this additional strength to the material. The same thing we have represented here. Generally, 2x series, 6x series, 7x series. These we can group it as heat treatable alloys. Normally, the heat treatment cycle that we practice is generally practiced is solutionizing and artificial age hardening. Why we call it as high strength aluminum 7x series? Some indication I have tried to give. So I think 5x you have mentioned there. You can see. So 1x series, about 90 MPa. You can just check the 7x series about 500 MPa. So that means strength. It's an indicative strength I'm trying to show. So this 7x series falls in the group of high strength aluminum. As you can see there, though zinc is the major element, you have magnesium and copper and other impurities. So that's about the alloy designation system. Next, we'll just touch upon when you do the heat treatment, when we carry out the heat treatment, how things are designated. This is also extremely important. Okay. What is this temper designation system? So by looking at the number, we should be in a position to understand, what is the heat treatment cycle it has undergone. That is extremely important. See, for example, F means it is, you should understand it is a fabricated product. O is annealed rod products. X stands for strained rod products. W only solution treated. And T means thermally treated. Okay. So something like that it is there. I'll just come back to this again. So if you refer to that, these are the designation systems. So starting from T1 to T10 it is there. Okay, so this is actually the normal designation systems we follow. In fact, morning when I was Dr. Bhatt mentioned, in Russia, though we say it is T6, they refer it as T1. I was asking why they took 11. Why do they confuse? So we say here we say T7. From Russian perspective, it is T2. He was mentioning today morning when we were traveling. So what is this T1? T1 stands for this. See, it is cooled from elevated temperature. It is cooled from elevated temperature shaping process and naturally aged and substantially stable condition. And next you see T2, it is cooled from elevated temperature shaping process, cold work, then natural aging. T3 stands for solution heat treated, cold work and naturally aging. So what is the difference between elevated temperature and this solution heat treated? Both are in all this particular series, aluminum alloy will be at some temperature. You are going to cool it either by quenching or by putting it in water or something like that. So those are first two let us say you are doing some hot working on it. From hot working directly you quench it and allow it to natural age and start using it. Whereas in T3, you